wipe off a lot of this stuff. Okay. Are you ready to go?
Yeah, it's already on.
Oh, it's already on? Okay, cool. Alright, so we're going to do the training for the Discovery DSC. So the DSC essentially stands for Differential Scanning Calorimetry. And what it's able to do is measure the thermal transitions within your material, whether that be glass transitions, melting, crystallization, things like that. In terms of this instrument itself, its temperature range is from minus 90 degrees Celsius to 400 degrees Celsius. In order to go to 550, as it is on here, we actually need to change some things out. So currently it's set at 400 Celsius as the upper temperature. What you can do in here, as I was mentioning, is looking at melting crystallization, glass transitions. You can do some variant of kinetic analysis and other types of experiments like that. What you will not be able to do, or what is definitely not recommended, is to degrade your material in the actual DSC. That's definitely one thing that we do not allow. So how does this actually work? We will go over here and sort of look inside of the instrument, and I'll show you what actually makes this a DSC. In here is essentially the main part of the instrument. Can you see in here? Or you can come closer if you want. You can come closer if you want. So alright, so basically inside there is this larger outer silver piece. This is actually connected to this hose, which is connected to a chiller, and that provides us with our lower temperature of minus 90 degrees Celsius. So basically this is our heat sink right out here. Inside this inner circle is actually the furnace. So that actually is what heats up. So that's what gives us our upper temperature. This furnace is actually made of silver. As a standard user, you should not ever need to touch anything physically in here. Everything that operates in sort of this region is all automated. Your only responsibility is preparing your sample and placing it on the auto sampler, which is over here. But inside of this block, of this heating block, there are basically two little posts. One holds your sample, and the other one is for your reference. So the first word in the differential scanning calorimetry is differential. So you're actually measuring the difference between two things, and that's why the reference is important, because for example, if I were to have two empty pans placed in here, in a perfect world, nothing should happen, right? Because the comparison between these two things as I heat them up should be exactly the same, so there should be no differential changes occurring, right? However, if I then put a sample in one of them or some sort of material in them, now there's going to be a difference. That difference could be because that sample is going through their glass transition, it could be the sample is melting, or it could simply be the heat capacity of the sample that's different from what it would be if it was an empty pan. So all of those things essentially can be detected by this instrument. And that's why it's called a differential flow, because you're actually measuring, or you're comparing that heat transfer between the material and this furnace and the empty pan and the furnace. So the difference between those two things is what actually provides you your signal. Like I said, in here, you should have no hands. Of course, wear gloves. But generally, the standard user should not need to put their hands in here. There is an arm that will come and take your sample and place it inside, take the reference and place it inside. So nothing in here should be essentially interfered with. At the back side here is the auto sampler. There are 50 different positions for the autos to place your sample. You can see now, you can see that there's quite a few samples already here. If you leave your sample here after your experiment, I will assume that you no longer want it, so it will be thrown away. So basically right now, for example, I have to clean out a few of these because I know that they've already been run. But essentially, you will pick an empty slot, for example, number 35 here, and place your sample, your prepared sample in there to be tested. You would have to remember where you position your sample because you would have to tell the instrument when you're preparing the experiment which sample to take. There are 50 sample positions, and there are also 5 reference positions labeled R1 through 5. Currently, R1 and R2 are the only ones that we use, and they represent the 2 different types of pans that we have available for you to prepare your sample. So when you're preparing your sample, and as I will demonstrate later on, you want to select the same reference pan as your sample pan. So if you're preparing your sample pan in what we call a standard aluminum pan, you will choose reference 1. And if you're preparing it in your what's called a hermetic pan, you will choose reference 2. So be sure that whatever pan you prepare your sample with, that's the pan that your reference should be selected. And of course, that goes without in the same description as looking at your differential heat flow. If you have 2 different types of pans, then you have a differential heat flow that's based on the fact you just have 2 different pans, not on anything that's actually related to your sample. So always make sure that you have this same reference and sample pan prepared. The sample pans are typically empty, so there's typically nothing in them. There are some cases where you would need to have something in the reference pan, but those are sort of more specialized, more sensitive experiments. But for 99.9% of people, you're going to have an empty reference pan. And because they are empty, they are reusable. So typically, I will switch out these pans, maybe every month or so as people use them, just to get a fresh pan in there. But because they are empty and there's nothing in there, they're fully reusable, as long as they haven't been dirtied in any way. Okay, so that's basically the sort of physical demonstration. So like I said, there is an automatic arm that will come. It will take your sample, it will place it into the furnace, it will take the reference and place it into the furnace. So nothing in here really needs to be touched with the exception of you placing your sample in the correct position. So essentially what happens, there is a lid. There are actually 2 lids in there, one that closes right on top of the furnace itself, and basically this outer lid that sort of keeps things insulated from any outside temperature variations. And basically once that's closed, and you set your program and you hit start, it will start running and start recording data. All right. So that's basically how this operates. And you can also see that when you were looking in there, it's a very small space. There's a small volume of space in there, and there's not a lot of room for things to expand and gas turn into gas and things like that. So that's why decomposition of your material is really not allowed in there. If it does happen, it can actually cause either some time in terms of having to clean the furnace itself, so that other people coming after you would be able to use a properly set up instrument. So please try not to decompose your materials in the cell.
So actually, which means that we don't really need to open the lid.
No, you don't physically open the lid at all. Everything is controlled through the computer. These are just manual controls for other cases where I may be troubleshooting things or things like that. But the standard user will always operate through the computer.
And we just need to put a sample into the auto sampler.
Yeah, you just put your sample in the correct auto sampler position, and everything else is done through the computer. You'll select what position you are. You'll select your reference sample. All of that's done through the computer, and the computer operates the furnace and the auto sampler arm to do everything else.
And obviously, we need to clean the furnace.
Yeah. So cleaning the furnace and things like that will be done by the person responsible for the instrument, and things like maintenance and calibration and things like that. It's for the advanced user, the person that's running the controlling the instrument, not for the standard user at all. Okay. Okay, so that's basically how that functions. There is a touch screen here. My only warning really is that sometimes it does freeze, so it may say idle up here, but sometimes that's not actually true. So always double check the computer to make sure that somebody's sample isn't running and you're not doing something that may jeopardize that. Just back on the note of degrading your sample in the DSC, I can't say it enough times because I've seen it happen a lot of times. Another reason why you don't want to degrade things in the DSC is because, for example, if you spilled something in there, it's going to stay in there. So if you run a sample immediately after that, then your sample is going to contain not just what you planned on having, but also the other thing that's spilled in there. So all these things can, introduce complications into your measurements. It can introduce inaccuracies. So try to be very careful once you're preparing your sample and how much sample you place in there. I'll give you a demo on how to prepare the sample and stuff towards the end, so that you know how to sort of remain in that safe zone, so that these things don't happen. All right, so moving over to the computer. So basically now I'm going to show you how to operate the software and how to set up an experiment on the computer and get things run. So the monitor, keyboard, and mouse actually controls two computers, top and bottom. The top computer is the DSC computer, and the bottom computer is a TGA computer. How do you know which one you're operating? It's by this little switch over here. If the green light says DSC, that's the one that you're operating. If it says TGA, that's the computer that you're looking at. In order to switch back and forth from each one, you hit the scroll lock button twice. And you will see the screen go black and then turn into what is now the TGA computer, and you will also see the green light would switch out as well. You hit it again, and now the green light switches back and you're back onto the DSC computer. Make sure that you're on the right computer before you sign in, so that you're not setting up experiments on the wrong instrument. Also, the instruments operate the exact same software. So make sure that you know which one you're on before you actually go into the software.